In the previous video, we looked at volumes and how containers within a pod can share data with each other, and how a container can persist data even when it restarts. The volumes were part of the pod specification and are created and deleted with the pod. In this video, we will look at persistent volumes and persistent volume claims. Persistent volumes allow administrators to provision volumes that can be used by pods. They're managed by administrators using code similar to how deployments are managed by users. Persistent volumes abstract over the actual storage implementation by providing user with a storage class type. When a pod needs to use a persistent volume, it specifies a persistent volume claim, which is a request to use a persistent volume. Let's see a persistent volume in action before we get into more details. Similar to the example before, we will create a persistent volume of type host path since that is what Minikube supports. We wear the administrator's hat and then create the persistent volume. We first write the API version, followed by kind, which is persistent volume. In the metadata, we give a persistent volume a name called HTML. In the persistent volume specification, we give the access mode as read-only many. Note that the access mode is important when writing a persistent volume claim, since the controller will try to match the access mode between the volume and the claim. Storage class name tells Kubernetes where we want to get the storage space from. Storage classes are defined by the administrator, and a persistent volume claim storage class needs to match the storage class of the persistent volume. We will look at storage classes in more details later on. For now, we use the storage class as manual since we are using a mounted directory. Capacity defines the capacity for the persistent volume. Any claim that is less than or equal to this capacity will be fulfilled by this persistent volume. Hostpath is the path on the host, in our case Minikube, that provides the storage. When we apply this persistent volume, Kubernetes will create an object and make it available for any pod that requests it using a persistent volume claim. Next, we create the persistent volume claim that a pod can use to claim the storage space. The API version is v1, the kind is persistent volume claim. In the specification, we give the same storage class that we used while creating the persistent volume. The access mode needs to be the one that can be satisfied by the persistent volume. The resource request should be one that can be satisfied by the persistent volume. In this case, the request storage of 50 MB can be satisfied by a persistent volume of 100 MI. If we had one with 50 MI, that would be used first. If there is none, then the controller waits till it finds a persistent volume that can satisfy its request and then binds to it. We now modify a static website pod to use this persistent volume claim. First, we create a volume using the persistent volume claim. We call the volume HTML volume and use the HTML claim that we created earlier. The last step is to add a volume mount to our pod specification and use the name of the volume as HTML volume and path as engine stock root. Let's see them in action. First, we create the persistent volume. Let's see if it has been created by typing in kubectl get persistent volumes. Our HTML volume has been created and its status is available. Next, we create the volume claim. Once it's created, we check its status. A claim of name HTML claim has been created and the status is bound since it's now bound to a persistent volume. Let's see how the persistent volume looks now. Its status has changed to bound since we have used it with our HTML claim. We can now deploy a static website with this volume. This will create a static website and bind it to the volume. We can look at the pod details by doing a describe on the pod, and it shows a persistent volume. Let's test a static website. Now that we have seen an example of persistent volume, let's get into some details. We saw the storage class option, which gives the underlying storage type. In a production cluster, the administrator will create a storage class that can be used to create persistent volumes. Here are examples of storage classes. The storage provider is specified using the provisioner tag. The administrator can create multiple storage classes for say AWS depending on the backing storage type. In our example, we created a static persistent volume and a persistent volume claim and used that in our pod. However, certain provisioners allow dynamic creation of persistent volumes. That is, we don't create a persistent volume, but whenever a persistent volume claim is created, the provisioner dynamically creates a volume to fulfill that claim. Another option in the storage class is the reclaim policy, which is used for dynamically creating persistent volumes. They can take the values delete or retain. A few storage classes can use the wait for first consumer volume binding mode option that delays binding between the persistent volume and persistent volume claim by creating the bind only when a pod is created. The default value is immediate. The delayed binding can make sure that the volume is created in the network location that fulfills any pod requirements. This finishes our video on persistent volumes. In the next video, we will look at how configuration is passed to Kubernetes using config maps and secrets. See you in the next video.